Hello, welcome to this video. My name is Jean Dantrom, and I am a project officer in Aerospace and Technical Standardization in ANEC GIE. Today, we are going to have a look at the main existing standards dealing with space debris mitigation. These standards mostly originate from ISO, since they are of interest at the international level. In that frame, there is a reference document, which is the standard ISO 24113 Space Debris Mitigation Requirements. It was initially published in 2010 and is today as its third version from 2019, which is currently being revised. The subcommittee ISO TC20 SC14 Space Systems and Operation is responsible for this standard. This document is a top-level standard setting general requirements that are then detailed in lower-level documents which focus on specific aspects of the reference standard. ISO 24113 gives a definition of space debris as objects of human origin in Earth orbit or re-entering the atmosphere, including fragments and elements thereof that no longer serve a useful purpose. The requirements established by this document aim to achieve the following objectives: reduce the growth of space debris by acting on future designs and operations, and make sure that objects re-entering Earth atmosphere cause no harm. So here we have the required actions to meet the objectives set in ISO 24113 and mentioned before. Avoiding the intentional release of space debris into Earth orbit during normal operations, avoiding breakups in Earth orbit, removing spacecraft and launch vehicle orbital stages from protected orbital regions after the end of the mission, performing the necessary actions to minimize the risk of collision with other space objects, and reducing the risk associated with re-entry, for example to people, property, and the Earth's environment. The requirements associated with each of these actions are detailed in ISO 24113. As an example, regarding the avoidance of breakups in Earth orbit, this standard gives the maximum value that the probability of accidental breakup of a spacecraft or a launch vehicle orbital stage in Earth orbit should have until its end of life. Such actions are especially important if the space object has one or more of the following characteristics: has a large collision cross-section, remains in orbit for many years, operates near manned mission orbital regions, operates in highly utilized regions such as protected regions, which are defined also in ISO 24113, and operates in regions of high debris population. Here are supporting standards of ISO 24113 dealing with launch vehicle orbital stages, which, as the name suggests, is the element of the launch vehicle that achieves orbit. ISO 20893 gives a detailed and practical set of requirements and recommendations to help comply with ISO 24113 regarding avoiding the release of space debris, disposing of a launch vehicle orbital stage after the end of its mission so as to avoid a breakup in orbit and so as to minimize interference with the protected regions, and safely re-entering a launch vehicle orbital stage. ISO 16699 addresses the disposal of these orbital launch stages. Disposal is the process of removing the space object from the protected regions of space so as not to collide or otherwise interfere with the other users of those protected regions in the future. Disposal refers to maneuvers and passivation of energy sources, if applicable, after releasing the spacecraft. The standard proposes several disposal options depending on where, meaning what orbit, the launch vehicle is operating, so as to minimize interference with the most commonly used orbits, such as LEO or GEO. This standard is currently under review, as ISO standards are revised every 5 years. ISO 27875, Re-entry Risk Management for Unmanned Spacecraft and Launch Vehicle Orbital Stages, helps to assess, reduce, and control potential risks posed to people and the environment on re-entry. We can note that it has been amended in 2020 with a modification of the formula used to obtain EC, the expected number of casualties. Moving on with ISO 14200, which specifies guidelines and requirements on a common process for selecting and implementing meteoroid and space debris environment models. It is valid for altitudes below GEO plus 2000 kilometers. ISO 16126, assessment of survivability of unmanned spacecraft against space debris and meteoroid impacts to ensure successful post-mission disposal, defines the requirements and a procedure to assess the survivability as mentioned, and also describes 2 risk analysis procedures. The document is currently being updated. Some more supporting standards with ISO 27852, which gives a process for the estimation of orbit lifetime, modeling approaches and resources for solar and geomagnetic activity modeling, resources for atmosphere model selection, and approaches for spacecraft ballistic coefficient estimation. These results from this orbit lifetime estimation can then be used to make sure it complies with the requirements of ISO 24113. This standard is also under review. ISO 11227, test procedure to evaluate spacecraft material ejecta upon hypervelocity impact, is applicable to spacecraft and launch vehicles operating in all types of Earth orbits. The experimental procedure defines the type of facility to be used, the size, velocity, and type of projectile, the evaluation of impact ejecta released, the reporting of test results, and the quality requirements to be used. It provides data that need to be taken into account in the selection of outer spacecraft materials, though the selection is not based on these criteria alone. It was reviewed and confirmed in 2017 and has recently been amended for the oblique impacts and Annex C with a modification on the ejecta measurements methods. This is the last ISO standard that we'll talk about today. This project will incorporate the content of the current standards into one single document. So we have one standard to estimate the mass of remaining usable propellant, one to prevent breakup of unmanned spacecraft, both during and after the operational life, and 2 more standards which propose several options to dispose of satellites from LEO or GSO, depending on where, so what orbit, the spacecraft is operating, so as to minimize interference with the most commonly used orbits, such as LEO or GEO. Here are some other documents, not standards but technical reports. The difference is that the technical reports may include data obtained from a survey, for example, or from an informative report, or information of the perceived state of the art. So we have 2 technical reports on the design and operation of spacecraft and launch vehicle orbital stages for space debris mitigation. The third one is under publication, avoiding collisions among orbiting objects, and will replace another technical report. You can see the change in the title between with and among the orbiting objects is including a broader range of possible events. The document describes some widely used techniques for pursuing close approaches, estimating collision probability, estimating the cumulative probability of survival, and maneuvering to avoid collisions. So this is just to mention that there is also a European standard equivalent to ISO 24113 that includes some notes and clarification on that standard for application of the European space standards based on ECSS. Now, if you want to consult standards, all the standards mentioned in this video, as well as many others, can be consulted free of charge via one of the 9 reading stations in Luxembourg. They are available in read-only mode with no obligation of buying. The reading stations are spread across the country to facilitate access to them. These standards can also be purchased on the INAS eShop, where you can also access the standards under public inquiry that I mentioned in this video. You can find them among other national, European, and international standards in PDF format with single user or multiple user license. We have reached the end of this presentation. Thank you for your interest, and feel free to contact me using the information provided here should you have any questions.